Hi guys, it's Mr. Hunt here again, and today we're going to be looking at plotting some slightly harder straight line graphs. So these won't just be vertical or horizontal, these are going to be a little bit diagonal as well, which is why I introduced you at the end of the last lesson the graphs y equals x and y equals minus x. If you remember, those were just two diagonal lines going through 0, 0. We'll have a look at that in a bit more detail in a bit. But for now, what we're going to do is going to start off by looking at using a table of values to plot a graph. In this case, the graph is going to be y equals x plus 2. Now, if we remember back to the last lesson, we remember that when we had the graph y equals 3, that meant that all y coordinates equaled 3. When it was x equaled 4, all the x coordinates equaled 4. When it was y equaled x, it was that the y coordinate was exactly the same as the x coordinate. Okay. Now that was the sort of the basics. That leads on to this. If y equals x meant that the y coordinate was the same as the x coordinate, what this equation means is that the y coordinate is the same as the x coordinate, but with 2 added on. So we've got a table of values drawn out here with several different numbers for x. So the x coordinate here is 0. So the y coordinate is the x coordinate plus 2. So the x coordinate is 0, y coordinate is 0 plus 2, which is 2. X coordinate is 1. So the y coordinate is going to be 1 plus 2, which is 3. X coordinate is 2. Y coordinate is 2 plus 2, which is 4. 3 plus 2 is 5, 4 plus 2 is 6, and 5 plus 2 is 7. So we're able to generate a table of values by using the equation, just thinking about what the equation tells us. Okay, so now we've got our table of values, we can draw ourselves a set of coordinates, a set of axes, and we can start plotting them. So let's get rid of that. So we can start plotting them. So 0, 2, 0, 2 is there. 1, 3 is here. 2, 4 is there. 3, 5 is there. 4, 6 is there. And 5, 7 is slightly off the graph, is there. So you should notice that these guys are all in a straight line. And we can connect that using a ruler. And that's all we really have to do. So connect that using a ruler. And that's our straight line graph. Obviously, I haven't got a ruler on here, but you get the idea. So with these tables, I'd like you to pause the video and have a go at doing these, seeing how well you can do. Just copy and complete the tables for now. Don't worry about drawing the graphs, just get the tables drawn. So pause the video, have a go at doing the tables. Okay, so hopefully you've only got doing these tables now, and you've got the following things. So y equals x plus 4 means that the y coordinate is the x coordinate plus 4. 0 plus 4 is 4. 1 plus 4 is 2 plus 4 is 3 plus 4, 4 plus 4, and 5 plus 4 gives us 9. Okay. Over here, it's y is the x coordinate, take away 1. So the x coordinate, take away 1, is going to be minus 1. 0, 1, 2, 3, and 4. Here, the y coordinate is 2 times the x coordinate. So that's going to be 0, that's going to be 2, that's going to be 4, that's going to be 6, that's going to be 8, and that's going to be 10, because we're doing 4 times 2, 5 times 2, 3 times 2, 2 times 2, 1 times 2. Down here, it's y is 3 times the x coordinate. Yeah? So 3 times 0 is still 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9, 12, and 15. So we can complete the tables nice and easily. Not going to bother with these ones. These ones here, slightly trickier. So, okay, so I'm going to show you the first one and then let you guys do the next ones. So we're using BIDMAS. This means that the y coordinate is 2 times the x coordinate plus 1. So we do 2 times the x coordinate, 2 times 0 is still 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. 2 times 5 is 10, plus 1 is 11. Okay, down here, let's do the same thing. This time it's 3 times the x-coordinate plus 4. So 3 times 0 is still 0, but plus 4 is 4. 3 times 1 is 3, plus 4 is 7. 3 times 2 is 6, plus 4 is 10. 3 times 3 is 9, plus 4 is 13. Then we've got 16 here. 3 times 5 plus 4 is 19. Okay, so that's how you do the tables where you've got things that look like this. And it should be hopefully quite straightforward for you. Just substitute in your x value. And you do whatever it tells you to do. So times it by 2, add 1. Down here it'd be times 2, take away 1. Times 3 plus 4, times 3, take away 1. Okay, and then we've got some negatives involved. But yeah, okay, so these are the sorts of questions you're actually going to be given. So draw a graph of y equals x minus 2. So you're not given a table of values, so you have to draw your own. So because they've got some negatives involved, it helps have some negatives. Then let's do it. Y is the x-coordinate, take away 2, so it's going to be minus 5. Minus 2 take away 2 is minus 4. Minus 3, minus 2, Okay, so generate your table of values. Next thing is plot some coordinates. So minus 3, minus 5, so that's minus 1, minus 2, minus 3. Minus 3 is there, minus 1, minus 2, minus 3, minus 4, minus 5 is down there. Remember, go along the corridor and then up the stairs. Minus 2 is there, minus 4 is here. Minus 1 is there, minus 3, 0, minus 2, 1, minus 1, 2, 0, and those are our last points. You then connect them using a straight line, and that's your graph done. Okay? Label a line with what the equation is. Right. Cool. I think I've set this. This is a very nice task, actually. I think I'll set this as your work. So I'll upload this slide, and I'd like you guys to have a go at drawing the graphs using the video I've just done onto a set of axes like this. Okay, cool. Well, if you've got any questions, please ask on Teams, and I'll do my best to help. Thank you very much.